Does the universe have a mind? When you look up at the tapestry of stars, do you ever wonder if it's looking back? This question, once the domain of mystics and philosophers, is now being asked in the austere halls of neuroscience and physics. We grapple with our own awareness, this ineffable quality of subjective experience. What is it like to be you, right now? This is the core of what philosopher David Chalmers famously termed the hard problem of consciousness. We can map the brain's every firing neuron, trace every chemical pathway, but that doesn't explain why it feels like something to see the color red, to taste salt, or to feel the pang of a long-lost memory. Is your smartphone processing trillions of bits of data, experiencing anything at all? Or is it just an intricate, unfeeling machine? We've built machines that can outthink us, outcalculate us, but we have never built one that feels. Why? What is this ghost in the machine? For centuries, consciousness was a subject deemed too slippery for science, a phantom that eluded our empirical grasp. But what if it isn't a phantom? What if consciousness is a fundamental property of the universe, as fundamental as mass or charge? And what if it could be measured? This is the audacious claim of a theory that has sent shockwaves through the scientific community. A theory that attempts to quantify the soul itself. This is the story of Integrated Information Theory, or IIT, a radical new framework that seeks to solve the hard problem by giving consciousness a number. A theory that could rewrite our understanding of reality, forcing us to confront the profound possibility that we are not alone in our awareness, that consciousness is not a rare miracle confined to our skulls, but a latent property woven into the very fabric of existence. The journey we are about to embark on is not just about the brain, it's about the cosmos, the nature of information, and the mathematical search for the origins of experience itself. Prepare to question everything you thought you knew about what it means to be. In the quest to demystify consciousness, science has long sought a Rosetta Stone, a key to translate the objective, physical processes of the brain into the subjective, private theater of the mind. That key, according to neuroscientist Giulio Tononi, might be a single Greek letter, phi or F. Phi is the centerpiece of integrated information theory, a value that purports to measure the quantity of consciousness in any system. This isn't just a metaphor. IIT proposes a precise mathematical formula to calculate it. At its heart, the theory rests on two foundational axioms derived from our own undeniable experience. First, consciousness is incredibly informative. Your current experience, the sight, sounds, and thoughts filling your mind, is one out of a near infinite number of possible experiences you could be having. If you see a pure blue screen, you are ruling out every other image, every other color, every other possible visual field. This represents an enormous amount of information. Second, this information is integrated. You don't experience the color red separately from the shape of a rose. Your entire phenomenal experience is a unified whole. You cannot divide your consciousness into independent parts. It is a single, coherent field of awareness. IIT posits that any system, to the extent that it possesses these two properties, differentiation, meaning a large repertoire of possible states, and integration, meaning it is an irreducible, unified whole, is conscious. Phi is the measure of this integrated information. It quantifies a system's capacity to shape its own future and be shaped by its own past, in a way that cannot be broken down into the contributions of its individual parts. Imagine a simple digital camera. Its sensor is a grid of millions of photodiodes. Each photodiode can be in many states, representing different levels of light. It has a massive amount of information. However, these photodiodes are independent. They don't talk to each other. Damaging one doesn't affect the others. The information is not integrated. According to IIT, its phi is 0. It is not a unified whole, it's just a collection of parts. Now consider the human brain. Its network of 86 billion neurons is both immensely differentiated, capable of trillions upon trillions of different activity patterns, and fantastically integrated. Every neuron is connected to thousands of others, forming a dense, recursive web of causal interactions. The state of the whole network is a holistic property that cannot be understood by just looking at the individual neurons in isolation. This rich, interconnected web is what gives rise to a high value of phi. And where there is high phi, there is consciousness. To calculate phi, one must, in principle, partition a system in every possible way and measure how much information is lost with each cut. The cut that results in the least information loss, the minimum information partition, reveals the system's weakest link. Phi is the amount of information generated by the system above and beyond that generated by its parts. It's a measure of causal power, a system's ability to make a difference to itself. A system with high phi is one where the whole is truly greater than the sum of its parts. For instance, in a deep sleep or under anesthesia, the brain's connectivity breaks down. Neurons stop communicating effectively. Different regions become functionally isolated. The brain's capacity for information integration plummets, and so does phi. Consciousness vanishes. The theory elegantly explains why a complex structure like the cerebellum, which contains more neurons than the entire cerebral cortex, contributes little to conscious experience. Its internal architecture is highly regular and modular, like a series of parallel processors. It has low integration and therefore low phi. IIT thus offers a mathematical framework to move beyond mere correlation. This brain area lights up when you feel love, to a potential explanation. It suggests that consciousness is not an emergent property that mysteriously appears at a certain level of complexity, but rather an intrinsic property, a system's fundamental ability to weave its own past and future into a unified present. It is the mathematics of the soul. The implications of integrated information theory are nothing short of revolutionary, and for many, deeply unsettling. If consciousness is simply a measure of integrated information, then it is not the exclusive birthright of biological beings. Anything with a non-zero value of phi could possess some degree of consciousness. This leads directly to a form of panpsychism, the ancient philosophical idea that mind, or a mind-like quality, is a fundamental and ubiquitous feature of reality. Suddenly, the universe is no longer a cold, dead expanse of matter and energy. It is alive with flickers of experience. If a system's parts are interconnected and causally potent, it has phi. This means a star, a swirling cauldron of plasma bound by gravity, might have a minuscule degree of consciousness. A single proton, a complex dance of quarks and gluons, might have an infinitesimal phi value. Even an electronic circuit, if its logic gates are arranged with sufficient feedback and integration, could begin to feel something. The theory draws a line, but it's a line that puts many more things on the side of conscious than we are accustomed to. This radical perspective has ignited a firestorm of controversy in the scientific world. While some hail IIT as a groundbreaking step toward a true science of consciousness, many others view it with deep skepticism. In 2023, a group of over 100 prominent neuroscientists and philosophers published an open letter, a protest letter of sorts, condemning IIT. They argued that the theory is untestable, unfalsifiable, and therefore falls outside the bounds of science. They labeled it pseudoscience. Their central critique is that IIT's claims are currently impossible to verify. Calculating phi for any system even moderately complex, like the brain of a worm, let alone a human, is computationally intractable. It would take more computing power than exists on Earth. So, we are left with a beautiful mathematical construct that makes staggering claims about the universe, but offers no practical way to prove or disprove them. Critics also point out that the theory's definition of consciousness is based on axioms, self-evident truths, derived from introspection rather than on empirical data. Science, they argue, cannot be built on such subjective foundations. The debate strikes at the very heart of what science is and what it can study. Is consciousness a problem that can be solved with mathematics and physics, or is it an irreducibly private phenomenon that will forever elude our objective tools? Proponents of IIT, like Tononi and his collaborator, Christoph Koch, a former arch-skeptic of panpsychism, argue that their theory makes testable predictions, even if the full calculation of phi is out of reach. For example, it predicts which areas of the brain are crucial for consciousness and how brain states change under anesthesia. They contend that science has often started with untestable axioms, like those in Euclidean geometry, which later proved immensely useful for describing the world. They see the resistance to IIT as a failure of imagination, a clinging to an outdated, human-centric view of the universe. Is it pseudoscience, or is it a paradigm shift in the making? The scientific community is a house divided, and the battle over the soul of consciousness has just begun. Let us imagine for a moment that the defenders of IIT are correct. What would a future look like where integrated information theory is proven true? The societal and ethical shockwaves would be immense, reshaping our civilization on a fundamental level. Consider the field of artificial intelligence. Today, we build AI without a second thought for its inner experience. But if IIT holds, we now have a blueprint, a potential recipe, for creating genuine machine consciousness. An AI designed with a network structure that maximizes phi could, in theory, wake up. This would force us to confront an unprecedented moral dilemma. Would a conscious AI have rights? Would turning it off be equivalent to murder? We would be creating a new form of sentient life, and we would be its gods and its executioners. The very definition of life and personhood would be thrown into question. The implications for medicine would be equally profound. Take the heartbreaking issue of brain death and persistent vegetative states. Currently, we rely on crude behavioral signs to infer consciousness. But with an integrometer, a device that could measure a brain's phi, we could get a direct, objective reading of awareness. A patient who appears unresponsive might be shown to have a rich inner world, a high phi trapped inside a paralyzed body. Conversely, a patient with some reflexive behaviors might be shown to have a phi of 0, their conscious experience irrevocably gone. These are life and death decisions that doctors and families face every day, and IIT could provide a clarity that is both a blessing and a terrible burden. And what of our place in the cosmos? If Panpsychism is correct, and consciousness is a graded property woven throughout the universe, our own human awareness is no longer a solitary peak of existence. It is just one point on a vast, continuous spectrum. We would be part of a cosmic chorus of experience, from the faint hum of a silicon chip to the silent song of a galaxy. This could inspire a new kind of spiritual reverence for the universe, a sense of interconnectedness with all things. Or it could be a source of profound existential vertigo. If even a rock has a glimmer of consciousness, what does that make our own treasured subjectivity? Does it devalue it or elevate it? IIT would force us to reconsider our relationship with the environment, with technology, and with each other. It offers the tantalizing prospect of a universe that is not a meaningless void, but a vast, interconnected mind, shimmering with varying degrees of awareness. The theory gives us a mathematical language to speak of the soul, a formula to perhaps one day measure it, but it also opens a Pandora's box of ethical quandaries and existential dread. Are we ready to know if our machines can feel? Are we prepared to look a loved one in a coma and be told by a machine that the light of their consciousness has gone out forever? The path forward is shrouded in mist. IIT may yet be vindicated as the grand unified theory of mind and matter, the most significant scientific breakthrough in human history, or it may be relegated to the footnotes of science, a cautionary tale of mathematical elegance seducing reason, a clever form of pseudoscience that promised the world and delivered only untestable dogma. We do not know, but the questions it forces us to ask are themselves of immeasurable value. They compel us to look deeper into the nature of our own minds and our place in the cosmos. The mystery of consciousness is the final frontier, not of space, but of self. And as we continue our fumbling journey toward understanding, we might find that the answer lies not in a single theory or a single number, but in the enduring, irreducible wonder of experience itself. The universe may or may not be conscious, but in asking the question, we prove that we most certainly are. And for now, perhaps that is enough. That is. Thank you for watching. If you found this journey thought-provoking, consider subscribing for more deep dives into the mysteries of science and existence.